Hi, my name is Baylee, and for my Physics 3 long term, I'm doing wind tunnel and wing lift. So, to build the wind tunnel, the materials that I needed were cardboard, duct tape, plastic, paper towel rolls, and straws. So you can see in these photos that I used the plastic to use as a viewing window so I could see the wings inside the tunnel. I used the paper towel rolls to direct the flow of the wind. The cardboard and duct tape I used to assemble the wind tunnel, and the straws you'll see in upcoming slides I used to hold the wings inside of the tunnel. So my question is, how will the height of a wing affect its lift per second? My claim is that I believe the larger the height of the wing, the less lift per second it will have. So for my procedure, I'll create 2 different shapes of wings and make 3 different heights of those 2 shapes of wings. Then I'll put them each into the wind tunnel to see how much lift per second that they'll have. And to figure out the lift, I drew lines on the straws to indicate how high the wings will be lifting in centimeters, and you'll see this in the next slide. And I'll have the wind tunnel on for 10 seconds to calculate the lift per second for each trial. So to build the wings, I used paper, tape, and straws, and for shape 1 and 2, I used 1, 2, and 3 centimeter heights. And in these photos, you can see the lines that I drew for the centimeters so I can see how high the wing is lifting inside the tunnel. So the one problem that I had was that the wings would not stay inside the wind tunnel, so I had to add paper clips to add weight to the wings. And once I added 7 paper clips, they both stayed in the tunnel and they both had lift at the same time. So for my first shape, first centimeter height, for all 5 trials, it had the same lift per second at 0.3 centimeters per second. And I have a video for each of these wings and their heights to show you how it worked. So this is the video to show you the first shape of the 1 centimeter height. So for my first shape, it's 2 centimeter height. Trial 1 and 2 were 0.35 centimeters per second. Trial 3 was 0.4 centimeters per second. Trial 4 was 0.35 centimeters per second. And trial 5 was 0.4 centimeters per second. So you can see it was all around the same lift per second, but they did vary a little bit. So here's the video for the 2 centimeter height of my first shape. So for my first shape of a 3 centimeter height, the amount of lift per second for trial 1, 2, and 3 were 0.4 centimeters per second. For trial 4, it was 0.45 centimeters per second. Trial 5, it was 0.4 centimeters per second. So you can see it roughly stayed the same except for trial 4. I'll show you the video of the 3 centimeter height now. So then I combined all of the trials of the first shape. So the 1 centimeter height is the blue dots, the red is the 2 centimeter height, and the yellow is the 3 centimeter height. So for my second shape of a 1 centimeter height, for trial 1 it was 0.35 centimeters per second. For trial 2, 3, and 4 it was 0.3 centimeters per second. And for trial 5, it was 0.35 centimeters per second. So again, it did stay in roughly the same range, but it did vary a little bit. And here's the video for this one. So for my second shape of a 2 centimeter height, trial 1, it was 0.1 centimeters per second. Trial 2, 3, 4, and 5 all stayed the same at 0.15 centimeters per second. And here's the video for my 2 centimeter height of my second shape. So for my final shape, the second shape, 3 centimeter height, all of the trials actually stayed the same at 0.1 centimeters per second of lift. And here's the video for this one. So again, I combined all the trials of the second shape. In the blue, it's 1 centimeter height, the red is 2 centimeter height, and the yellow is 3 centimeter height. So then I took the average lift of all the trials of shape 1 and shape 2. And for shape 1, which is in blue, you can see that it increases as height increases. And then for shape 2, which is in red, the lift per second decreases as height increases. So in conclusion, I saw that wing shape 1, the lift of the wing increased as the height of the wing increased. However, for wing shape 2, the lift of the wing decreases as the height of the wing increased. So overall, I feel like the height of the wing affects different shapes of the wing. So for shape 1, the lift increases with height, whereas shape 2, lift decreases as height increases. So it kind of varies between what kind of shape you're making. So that concludes my presentation. If you have any questions, please let me know. I hope you enjoyed.